So I'll just give a brief introduction about myself. So my name's James Tan. I've been working with Unreal Engine for about 13 to 14 years now. And together with me today, we've got Markus Arvidsson. So together, we both worked together as programmers on a couple of games. One of the games was called The Ball, and recently we also finished up The Haunted. So after the session today, we're going to be hanging around. If you've got any more questions about related to the session right now, or any other questions about UDK, we're more than happy to answer them. I've also got Johnny Costello here as well. He's from NVIDIA. So if you have any questions about physics or that sort of stuff, then he's definitely there that you can ask questions. So in this session, we're going to be looking at a racing game that I made for Unreal University. And the majority of the logic was actually controlled by Kismet. So it's a really nice flow-on sort of a session. So I'm just going to open it up now. Right. So prior to Lee's session, how many of you guys have actually used UDK and Kismet? Have most of you guys used it? Cool. So most of the guys in the front. I can't quite see it at the back because of the lights, but let's try that again. Okay. So for those of you who haven't been on the UDN before, if you jump on the UDN, which is at udn.epicgames.com later on today on your own laptops or whatever, this racing stuff and all the content and the scripts and stuff is actually available on the UDN, so you can actually download that all. So don't be too scared that once you go away from the session that all this content is not going to be available for you. All right, while that compiles the shadows, we can... Okay, all right, so Unreal Script, which is the programming language that we use in UDK, in this particular game, it only controls really low-level things. So it sets up things like the vehicles, for example, and we don't really want Kismet to handle this, just because it's kind of a low-level thing. Like all it does is just handle like the wheels and the spinning and the suspension, and you want that to be driven by physics, right? So Kismet is used for really high-level stuff, and so with the vehicles, that's all done by Unreal Script. And so really, what we want to use Kismet for is control most of the gameplay logic. So like the scoring, how you actually set up the controls for controlling the vehicle. Because we wanted to have this racing game actually playable on the iPad. That was one of the key goals as well. Some other things that we did was I actually used the Unreal Script for controlling the camera. I could have done this in Kismet as well, but I decided that I needed a little bit more control because the camera is kind of outside the vehicle and it's looking towards the vehicle. And I could have done this as Lee demonstrated. But it needed to do other things as well, such as trace backwards to check for like objects, so that you didn't have the camera in the middle of like the rocks or something like that, so that it would move forward and backwards. And you sort of want to control that using script as well, just because it's a little faster performing. Kismet's really great when you have triggers and events that happen every now and then, but for things that happen every single frame, you really want to shift that over to code. Just going to grab a cup of water, just turn this off first. So yeah, it just handles the camera location and rotation. And also some lower level stuff such as the game info, the pawn and the player controller. We actually had an earlier session today that talked about the platformer game, and I went over these classes. So I think there's going to be some recordings of all the sessions today. So if you weren't here for the platformer one, you could probably find that online and listen to that to get some information about the game info, pawn and player controller. And really what those classes do is a really brief thing. It just sort of handles the game rules and the player interactions. So the player controller, for example, handles the key inputs. So as I'm moving the mouse or as I'm pressing the buttons on the keyboard, it just receives those and forwards that on to the rest of the game. We also made a custom Kismet sequence as well. One of the really cool things about Kismet is that it's actually built on top of Unreal Script. And so if you need really, really precise or other types of functionality that Kismet doesn't have when it comes, when you download UDK, so sorry, what I meant was, so if Kismet out of the box doesn't come with something that you want, you can actually program that yourself, and so that you have specific Kismet nodes for your game. And lastly, the vehicle and the vehicle wheel construct. You have to make these in Unreal Script. It's a little bit too low level for Kismet to deal with. Okay, so we're going to jump into the Kismet stuff right now. Okay, so this is the racing game. Just chuck that on the other window. So it's actually a variation of the Epic Citadel map. I'll just briefly actually just start the game, and you can sort of see what the game is doing, and then I can reference each part and how I did it in Kismet. So when the player first starts the game, which screen is it going to go onto? All right. So when the player first starts the game, he gets presented this window, and this viewport, and it's sort of a matinee that does sort of like a fly through the level. And there's some text in the screen that just says, you know, tap to start. I actually forgot to turn on the emulate mobile. Right, so when I press the mouse, so I've got the car there, and I've actually got the iPad controls here.
Easy left.
And as I'm moving my mouse, I'm actually left clicking, that simulates the touch. Unfortunately, it's very hard to play this game with just a single input, such as just the mouse. But you can sort of see what the game is doing. As I'm sort of progressing through, I get some track signs, and I get some points based on how fast I was, how quickly I went to each checkpoint. If I fall off the map, or flip upside down, like I'll drive into the river here, it automatically teleports me. I can also, if I'm unhappy with where I am at the moment, maybe I got stuck on some other random piece of geometry like this bridge here, I can press this button and it'll reset me as well. So all of that was set up in Kismet. So one of the things about Kismet is, as Lee was saying, is that it's really easy for Kismet to start to get kind of messy. You have all these variables everywhere, and you have all the lines linking to everything all over the place. And one of the things that you can use to clean that all up is to use global variables. And what we have here with global variables is that, you know, I have variables for things such as an object, which is signified by the circle with a purple border, and that variable just points to the player's vehicle at any given time. And then I have these other global variables, such as if this variable is true or false, then if it's true, then I draw the left turn sign. If it's false, I don't, and so on. So I have things like the current score, the previous checkpoint time, score per second, current score, and so on and so on. So what can we do with these? You'll notice that there's no links to those, so how on earth am I using them? What you can do from here is you can create a named variable, and basically this just acts as a pointer. How many of you guys come from a C++ background or have done? Okay, so it's basically a pointer. It's the same thing. Right now it doesn't have any names attached to it, so I've got this big X and question mark. So if I set the named field to the same as this one here, this variable here will just point to that there. Yeah, and once it points to an existing variable, it then gets a big tick and it sort of gives you the name. And so that can really help to clean up your Kismet a lot. So when you start to get to really big Kismet sequences, like the checkpoints, so basically I have lots of Kismet stuff, and I often need to reference to the current checkpoint. And so I have lots of pointers that just reference to the current checkpoint. But if I didn't do this, then I would have one current checkpoint variable and about 1 billion links to it, and you just see this a massive mess of spider webs. And this is one way that you can really help to keep your code, your Kismet code clean. And it's usually a really good idea to initialize these to something so that they actually make sense. So in the case of my global variables, I've set them to sort of default values as like false, 0, but you can set them to anything you want. All right. The other way that you can initialize these, like for example, I can't set the player vehicle to anything like right now because the game isn't running. So sometimes when the game starts up, for example, so the player spawned, I can grab the instigator, so the pawn that was spawned for the player. I can grab its property, for example, the pawn, and then I can immediately assign that to the player vehicle. And this way, that sort of global variable is initialized right at the start of the game. So we're going to look at the mobile platform Kismet stuff specifically right now. We're going to look at the input initialization and handling. So often UDK, when it ships, it has sort of like a default dual joystick sort of setup for you when you are using it on the mobile platform. But what you can do is you can actually reset all of that, and you can redefine the controls yourself. Right. So when the game restarts, I do this little thing here. So I clear all the current input zones, and I start setting up the steering wheel, the gas pedal, and the reset vehicle, which was the button in the top right-hand corner. And if you don't want to have to do this all the time, you can actually reconfigure, you can actually just adjust the configuration files, which define a default set of input zones. Or you can just decide to remove them all by using the clear input zone Kismet node, which is what I've done here. So the steering wheel input zone, the way that works is that I added a trackball zone. So basically that one just tracks where your finger is. And I forward its input to mobile_a strafe. And basically there are a whole bunch of magical names that you can assign to, and they do different things. So in this particular case, it forwards the results of the trackball into this variable which the player controller recognizes. Often, what you want to do usually is ask the programmer what variables can I use to do these particular things, and the programmer can often tell you. So in this case, I've also initialized the gas pedal, and that sends its input to mobile_a forward. So basically, I've got a trackball which you can move left and right, and that'll adjust the strafing, in this case, the steering left and right of the vehicle. And then I've got a gas pedal as well, which sort of responds to the up and down, and that forwards it to the mobile_a forward, which the player controller then it interprets that into forward and backward movement for the vehicle. And the reset button itself is actually hooked up to another Kismet event itself. And I'll get into that soon. So you can actually create as many buttons as you like on the screen using Kismet like this, and they can all respond to different Kismet events as well. So actually, I might show you that now. So when you reset the vehicle, I have a bunch of volumes here. So these ones are the ones that sort of are placed underneath the map, so if the vehicle falls into those, it resets the vehicle. But as you can see here, I've got a mobile button access, and that hooks up to the button that we created just now, so that the player can push this button and it will run through the same logic to reset the vehicle. So as Lee said, you can experiment around with a lot of these different Kismet nodes, and you sort of go, oh yeah, I see how that's starting to work. So one of the other neat thing about Kismet is that you're actually able to render text and textures onto the HUD. And this allows for even more rapid prototyping, so that you can actually start making your game feel a whole lot more solid. So in Lee's case, with his example, he could have actually added text to say, oh, you're now driving forward, or you're now driving backwards, or you're now turning left or right. And these functions here are basically inside new event HUD, and you've got draw image or draw text. And basically they have a whole bunch of parameters with them as well that control how they draw things. So in this case, I have hooked up to my booleans here, draw left turn sign, and so when that's true, it'll then draw that image. And I've done that for each of the different images that I've got. So for the track signs, as I drive over a checkpoint, it says, okay, now enable the rendering. So it sets this global variable to true, and then after some time, it then just sets this global variable to false. So that's how I got the track signs to appear and then disappear after some time. And you can you can change pretty much everything you want. So the display location can be set by by Kismet. So I've got a vector parameter here, which just sets where it should be drawing to. But you can expose a whole ton of stuff. You can expose the size of the texture, you can expose what kind of texture to draw, and so forth. Okay, so now that we know how we drew the track signs, one of the things that you may not have also heard is that as you're driving through the level, there's a copilot that actually says, oh, turn left now, or there's a straight bridge coming up across, just sort of like the rally games that you see quite often. And the way I've set that up is that I have a bunch of triggers along the map. So as you touch these triggers, it executes some Kismet. So I have one here, here, and so on. And you want these to be Kismet because you want the level designer to place these, because he knows exactly how the track should be handled, because he made it. So as these triggers get touched, there we go. So as these triggers get touched, I do a really simple comparison with the global variable. So if the left turn sign is already being drawn, then basically I just say that, well, it doesn't matter. I don't need to redraw it again. I don't need to set it to true again. So this is why I've got this branch here and it doesn't do anything. But if it's not currently being drawn, I then follow through and then I set the boolean to true. And then after some delay, 2-second delay, I then reset it back to false. And this is how you get the track signs to appear and then disappear. And while I'm doing that as well, I also make sure to turn off the other track signs as well, so I don't get these overlapping textures all over each other. And I've also actually got sounds that play back as well. So as these triggers get touched, they play back the appropriate sounds, such as easy left or hard right or so and so on. And as you follow through, you can sort of see them all in here. Easy right, medium right, so and so on. So that's how I added the track signs, and that's really simple to do. Okay, so adding the checkpoints. So as the player is driving through the map, you basically want it so that if the player decides to reset, maybe fell into the river, or maybe he's got stuck on a rock, he wants to be able to push a button so that he can just go, teleport me back to the last checkpoint that I crossed over. And this is easily done, again, by using triggers. But the nice thing about triggers is that they can actually look like anything. So I have these awesome apples here that, well, they're not really apples. They're more like nushy pears or something, or yeah, peaches. Anyway, so these basically represent my checkpoints. And basically, anything in the game can receive a touch signal from Kismet. It doesn't actually strictly have to be triggers. So it can be these peaches that receive touch events. And so I'm going to find this, well, it's a path node dynamic, but I'll find that inside Kismet. And so when that's touched, all it simply does is it sets the current checkpoint to a different path node, and it activates a remote event called calculate scores. So as you're progressing through the track, and as you're touching each checkpoint, it says, okay, the previous checkpoint is now my current checkpoint as such, and each time I pass through a checkpoint, I want to recalculate the score. So let's have a look at the gameplay logic where we calculate the score. So that's a pretty big thing. So the way the game decides, so the way I decided that score should be given is that between each checkpoint, there is a maximum number of points you can get between each checkpoint. Say like 5,000. And what you want is that depending on the time taken from checkpoint A to checkpoint B, is how much I should give to the player. So if the player took, say, 0 seconds, so he was instantly fast, then he should get all 5,000 points. But if he took, say, 3 seconds, then he should only get like half the number of points. Okay, so that's easy enough. So, but how did I do that? So each trigger point triggers a remote event. I think Lee's like inverted the mouse. It feels real weird. No. Anyway, so now, see, one of the things is that it feels really redundant, right? Because you've got the Kismet up here, and these things are just triggering that. So why not just do from here to here, you know, right? But I have quite a lot of checkpoints, so if I did that a million times, it really starts to get really annoying because then you have links that go up and 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 so on. So I decided to have it as these remote events, and that helps to really clean up your Kismet nodes as well. So you don't have lots of links crossing over each other and things like that. If you check online, there's probably dozens of screenshots where people are like, look at my overly complex Kismet because I can do it. But really, you want to try to keep it really simple. So anyway, when each checkpoint gets touched, it runs this event here. And one of the neat things that you can do with Kismet is that you can actually query things and grab property values out of them. So sometimes not everything has to be exposed by the programmer. You can actually just ask Kismet to grab some values for you. So one of the things that I found that you couldn't get very easily was actually the current time of the game. There wasn't a magical node that I could create. I could have written one myself, but I sort of decided, well, I'm sure there's a way in Kismet I could grab it. And it's actually this get property value Kismet node. And you saw that being used earlier when I wanted to grab the pawn from the spawned player. And what we're going to do here is grab the current time. And the way we do that is we first grab the world info. And the world info is sort of like a static singleton. The programmers will understand what I mean when I mean singleton. It's just sort of an actor which is present in every single world when you run it, and you can grab it from pretty much every single actor in the map. So this didn't have to be the player vehicle. This could have been like a path node in the map or whatever. It doesn't really matter. And the world info itself contains a variable that stores the time of that map. And so I grab the time seconds, and I then subtract it from the current time to the previous checkpoint time. And at the beginning of the game, this might just be 0. So from there, I decide to set the previous checkpoint to the time now, because I've sort of subtracted that value and I've got some value out of that. So I want to make sure to set the previous checkpoint time. So when I go over the next checkpoint, I can do the comparison again. Okay, so I have this variable here called score per second. And I've already subtracted the previous time with my current time. So the previous time might be 0, right? And my current time is now 10. So 10 minus 0 is 10. So the player took 10 seconds to get to this next checkpoint. Is everyone kind of following along with me? Cool. So I divide that with I divide the score per second, so say 5,000 with over 10. So if the player took 5 seconds, he'd get more points. Right? Is my logic correct? I think so. Okay, so I then add that result, that divided result, to the current score. And then from there, I store everything as floats. I actually have no idea why, because I end up casting everything to ints. But anyway, anyway, maybe I thought it was more accurate at the time because I was doing. I remember why. It's because I'm doing divisions. If you divide like 1 over 2 and they're both ints, it actually returns 0. It doesn't give you 0.5. So I think I came across a problem where I was getting 0 every time I crossed over a checkpoint. But anyway, this is just a nice hack to store everything as floats and then cast everything down to ints so that you don't get, so your score doesn't say 0.00000. It feels a lot worse when your score is filled with so many zeros. So then I want to display this on the screen. So when we played the game, you could sort of see the score up at the top here. So I convert it into a string. This feels real bad. It goes from float to an int to a string. So I convert it into a string so that I can feed it to the HUD event, which draws strings. For some reason, they didn't have a draw int or draw float, but anyway, it doesn't matter. If you need that in your game, then you can always make one in Unreal Script. So from there, I render the score, and I can also convert the score that I actually added onto the current score with that as well, so that I have 2 strings at the HUD, and the top one represents your total score, and then the one at the bottom represents the score that you just gained. And I do it in exactly the same way as the turn signs. So when I finally get all the way to the end, I turn draw last checkpoint score true, so it draws the text at the bottom of your current score, and then after a delay of 1 second, it turns that off again. So that's how I got it, so that as you drove over the checkpoints, you'd see the addition score, and then it would disappear after a while. Okay, so handling the end of the game. So I didn't play the game all the way through, but what happens when you reach the end of the race is that it goes into a more cinematic pose. Actually, I'll play through it now, and you'll see exactly what I mean.
Easy left.
It's not a very long race,
Easy right.
and I probably won't get a lot of points, but
Easy left. Medium right. Bang. Square left.
so I added some matinee in here as well, just to make the map a little bit more interesting.
Medium right.
Okay, so I'm not too far away from the finish line now.
Bang.
So you can sort of see all the different parts working together now. You can see as I'm driving over the checkpoints, I get a little score that tells me how much I earned. And then I've got the main score up at the top there. I've got the reset button in the top right corner.
Hard left. Square left. Hairpin right.
Right, so this is the finish line. Okay. Yeah, I love the way I finished this game, just smash into a wall to stop. So basically what I have at the very end here is I have a huge trigger, and basically it's quite a large trigger, so it's got quite a large radius. And as soon as the player drives over that, the game kind of goes into like a second state. So while it's in the second state, it tells you that the race is complete. It has a final, and it gives you like a final score, and then it just says if you want to race again, you can just press the tap key. So how did I make that? So Lee showed earlier in the previous session how to set the camera target. So I'll show you how I did that for those who weren't in the previous session. So when the game ends, because the player's car touched the trigger, I set the camera target to a different camera somewhere within the level, and lo and behold, it's just up here. From there, I actually clear all the input zones because I don't want the player to be able to drive again. I want him to sort of have a look at how well he's done. So by clearing all the input zones, I stop that kind of behavior, so he can't drive. I play a sound to signify that the race is now over. I then join a couple of strings together. From memory, I think I actually wrote this little Kismet node because there weren't any string functions that allow me to add two strings together. So basically, all I do there is add the final score together with the current score text, and then I add it, and then it outputs to in-game text. I then enable the in-game rendering, much in the same way that I do with the turn signs and so on. And I've cleared the input zone again. I think I forgot I did it earlier on, but in any case, it doesn't matter. I then add a restart game button. So basically, it's an invisible button which is over the whole screen. And if the user touches that, then it restarts the whole game again. And where that's handled is just down here. So basically, I have a input zone here, and it just goes to restart game. And what that does is that it executes this restart game function, remote function. And what that does is that it basically just clears, yeah, here it is. So it basically just clears all the input zones again and just resets it all up for the player. It resets all the variables to like 0 and whatnot. It resets the whole track so that the checkpoints is now back at the start and so forth. And that's basically how I did the whole thing. So that's basically the actual entire racing game. You can actually add a whole lot more stuff with Kismet as well. So you can add things like if a player drives into this section of the map, then he gets a massive boost of speed, or he drives into this section and then he gets like a massive deceleration in speed, or he can pick up some power-ups which give him the ability to jump over things or shoot stuff. You can do that within Kismet. But what I really wanted to show in this session today is that you can actually create like all the checkpoint stuff in Kismet, and you don't actually need to use script for that sort of thing. So we actually had a question in the previous session where somebody asked how you would debug stuff. And obviously with this, it's going to be really difficult to debug it by just using lots of logs. And one of the things you can do now in the later versions of UDK is you can actually set breakpoints and things like that so that when Kismet nodes get activated, it'll pause the game, and then you can have a look at the values, and then you can go to the next Kismet node as it executes down the line. So it's very standard for most programmers. Most programmers have in the IDEs sort of a debugger, and it works in the same way. So we're going to debug how scoring works. So we're just going to step through all of that. So I'm going to set a breakpoint at this remote event. So it comes up with a little red circle. So I'm going to start the game, And as I drive over that first checkpoint, it's going to pause the game, and then it's going to allow me to step through all the Kismet nodes.
Easy left.
If I touch
Easy
checkpoint.
Right. Easy
Oh,
left.
sorry. I did not turn it. You've got to actually turn on Kismet debugging. It's usually a good thing if you want to debug it. So sorry.
Easy right.
It's not letting me start the game. That's fine. Sorry. No, I'll just disable the flyby. I don't need that while I'm doing this. Okay. Okay.
Easy left.
Did that turn off? Huh. Anyway, okay, let's try that again.
Easy left.
Yeah, okay. So the debugger is now activated, and it's paused the game, and it stopped in where this happened. So you get details such as things like how many times this Kismet node has been activated, and at what time it was activated at. So as soon as I touched the checkpoint, it went to this remote event. It grabbed the properties out, and as you can see here, I've got an object which is world info underscore number 3. So previously, beforehand, we'd just see question mark, question mark, question mark, but now that value's actually been set. So we grab the property for the time sequence, which was 3.723. I can now step through. Oops. Did a whole bunch of stuff. Oh, I see. So as it stepped through, no, let me run through that again, because I skipped over too many actions, I think. Okay. So I grabbed the time sequence, which is now 9.91 seconds, or 999, and I step through. Stepping through too many actions all in one go.
Easy left. Easy left.
Okay. Okay, so it's actually processed a whole lot of actions all in one sweep. But you can actually investigate all of your values here to figure out what it's actually doing at each given time frame. So the previous checkpoint time, we can refer back to that global variable, and we can see its value has been set to 3.589, but it's probably at 0 beforehand. But this really allows you to debug through your Kismet stuff without having to rely on lots of log statements. If you want to, you can still use log statements in this. It's really not a problem, and you can sort of browse through the history to sort of see what the Kismet actions were doing. But this gives you a little bit of a nicer way of debugging exactly what's going on at any given time. You can sort of see what the variables are doing. You can sort of see what the results of some of that text is. You can sort of see what kind of score is given and what it's going to be doing next and stuff like that. So that one's quite new. But it basically gives you a whole lot more power and how you want to decide when you're making your new prototype or your new game. You can step through it and you can go, oh, okay, I see what I've done wrong. Or you can do this through someone else's Kismet stuff and you can see, oh, actually, that's how they did it. Okay, so for those of you who haven't been to any of these sessions, I'm just going to give you a really quick rundown of what kind of help you can get. So if you haven't downloaded UDK, you can grab it from www.udk.com. The Epic Games Forums has basically a subforum that's dedicated to UDK. There are lots of veterans on that site, or that forum. And basically we help out and try to make sure everyone can resolve their problems. And that is at forums.epicgames.com. And we also have the Unreal Developers Network as well. And that's dedicated to the documentation of UDK. So it's always been updated, lots of reference materials and tutorials added every month. And that's located at udn.epicgames.com. Cool. Well, that's the end of my presentation. We've still got about 15 minutes. I can either elaborate a little bit more about some of the stuff that we went through this session if I went through it over too quick, or I can open it up to questions. If you can, if you've got questions, if you can set up the microphone. Right. That's yeah. We can definitely help after the session's over, and we can go through that. So if anyone's got any questions, just feel free to step to the microphones, and I can. Yeah, just feel free to step to the microphones, and that way everybody can hear the question, and then that way I can also answer them all in one go as well.
How well would a game like this actually work on an iOS device?
So how would it actually work?
Like how well would it work?
How well will it work?
Yeah.
Works pretty darn well actually. In terms of performance, or in
Yeah.
terms of performance, performance was pretty solid. On the iPad 2, I'm sort of getting about 40, 50 FIPS pretty consistently. But most of the performance is not really affected that much by Kismet. Most of your performance is going to be things like really traditional things, such as how many polygons you're rendering, how much texture space you're using, what kind of memory space is the game using in terms of like sounds and music and stuff like that. So Kismet is actually it's actually pretty darn fast as well. It's not a big hindrance to use Kismet over, say, script. Yeah.
Okay.
Yeah.
Okay, cool. Thank you.
No problems. Cool. Okay. Well, I might elaborate on some of the on the points that I had in the lecture that I might have gone over a little bit too fast. I might actually talk a little bit about how we make custom Kismet nodes, so that way you can sort of get an understanding of how you would, as a programmer, make some new ones. So you actually need to go into Unreal Script. And Unreal Script is sort of like the programming language that's used by UDK. So we're going to look at the concatenate string Kismet node that I wrote. So basically, like any other class in UDK, we extend from an existing one that was written by the Epic guys. And this event here, activated, basically events are like functions, and they're executed by the engine code. So engine code being, say, C++. So when that code gets executed in C++, it says, in script, I want you to execute this function name activated. And here we've basically got, we just output the string result and concatenate with value A and value B. And depending on how the user wants to concatenate, we do different things. And we just basically set up some variable links down here, and that exposes the little nodes down at the bottom of the Kismet. So if you sort of go, if we look at the Kismet stuff, you can sort of see it in there. So checkpoints. So in the concatenate string function, which is, no, it was at the end game. So the concatenate string function, we have an A and a B and a string result. And you can see how that maps pretty much directly with code. So that's how you'd go about making these really simplistic kind of Kismet nodes to allow level designers to start being able to do a little bit more things. So you may want to have some that, so if the car was to go in a certain volume, then do these sorts of things, such as speed up the car or slow down the car or stuff like that. I can elaborate a little bit more about how I added the volumes so that if the player falls off the edge of the map, he'll get teleported back to a checkpoint. So the way I did that was I had trigger volumes, and trigger volumes pretty much act as invisible BSP that sort of exist on the map, and they do sort of localized effects if things go into there. They work in very much the same way as triggers do, but they allow you to use the BSP tools to define the area at which things happen. So here I've got some volumes, some trigger volumes, and they're green in color. So basically, if the car was to fall off the edge of the cliff here, it would eventually touch this volume here. And in Kismet, I can actually right-click that and find this trigger volume in Kismet, and it points me to this touch event. So when this trigger volume gets touched, it just sort of links to so I compare the objects, so I make sure that the current checkpoint isn't equal to none. And if it's not equal to none, I then teleport the vehicle to the current checkpoint. And I can play a sound as well. So that's the way the resetting of the vehicle works. So whether the player falls off the edge of the map and goes into water, then I just do this. I can link it up there. As you can see, I've got multiple trigger volumes, but I also have it hooked up to the button as well. So if the player decides to, input pressed, if the player says, I want to reset, you can just push that button and it executes the same Kismet code as well. Anybody have any questions that they might have come up with? Yep, okay. I can elaborate a little bit more about the input stuff. So if we go so with the inputs, add input zones, these are only specifically for the mobile stuff. So they usually don't work on the PC in the same manner, in that you can't say add an input zone that handles the keyboard. So these were specifically added for the mobile stuff. And you get a lot of options with these, such as zone. You can define what kind of input zone you want to add, such as buttons, joysticks, trackball, or sliders. And they do different types of interactions with the touchpad. You can map it to different keys. You can also map it to Kismet events, such as what I did below with the reset button. So with the reset button, how I did that was the event is looking for an input zone name, reset vehicle. And you can also map it to internal variables, which are handled by the player controller. And again, you usually get a list of these variable names from your programmer. You can add as many controls as you want into your Kismet games. And with that, it also allows you to provide a really nice interface. So in Lee's session, he had all these triggers. And basically, he had one to make that cube thing go forward, and he had one to make the cube thing go left and then go right. You can actually just map all of those things to buttons on the screen. And that way, you can have a much more intuitive control scheme if you wanted to make a cube racing game. Anybody have any questions? Nope. Still no? Okay. So we can elaborate a little bit more about how to handle restarting of the actual game. So I sort of briefly mentioned that all I did was just teleport the vehicle back to the starting position and then just sort of zeroed out all the values and bits and pieces like that. Sometimes you may actually also need to reset things like the doors, like I had that gate open up. You'll need to reset that. So how do we manage that in a really nice way? One way you can do it is that every time the player actually starts the game, it always executes the restart game. And that way you kind of know whether or not that function is working. You can also step through it with a Kismet debugger as well to make sure that all the values are being set to false or true or whatever else that you wanted. And it's often really nice when you start forming sequences like these subsequences, that sort of nicely isolate everything. So all of these Kismet nodes here are just to do with handling of resetting or restarting the entire game. And using things like remote events really help because then that way you're not tempted to sort of remake the functions in other places. You can just sort of isolate everything all in one go. And the other thing you can do as well, even though you're using remote functions, you can actually search for everything that's actually calling this as well. So you can find that it's being called here and it's being called there and so on. Great. Okay, well that's pretty much the end of my session. Don't have anything too much more to elaborate on. So once again, the content and source code is all available on the UDN. It's available on the development kit gems section of the UDN. So if you pop over there later on tonight or whatever, you can just download that and start messing around with bits and pieces as well. All right, thank you.